Hi, Assalamualaikum. We are from Group 4, here to present about the early flood detection system. In this group, there's me, Muhammad Farid, Muhammad Fatimi Al-Amin, Sharul Ameh, Muhammad Shakirin, and also Nurul Shamina. Assalamualaikum. Here is an introduction for our Tinkercad project, which is the early flood detection system. To put it simple, the current flood detection system is outdated and inefficient. It relies on manual readings of water levels, which is impractical for modern flood management. A more advanced flood detection system using GSM technology has been created, but it also has drawbacks. Early flood detection is crucial for minimizing damage. Arduino, an open-source electronics platform, offers innovative flood detection systems. Implementing Arduino-based systems enhances timely alerts and response measures to mitigate flood impacts. Here are the goals for our project, which is firstly, understanding the concept of an early flood detection system using Arduino. Secondly, emphasizing the advantages, factors to consider during implementation, and the potential challenges that may arise when using Arduino. And lastly, construct a circuit and schematic diagram for the flood detection system using Tinkercad.
Hi, my name is Sharul Ameh bin Abdul Majid, and I will explain about the theory for my part. So, what is a Tinkercad? So, Tinkercad is a robust web-based platform that allows users to design and create 3D models for various purposes, including rapid prototyping. So next, what is Arduino? Arduino is a flexible electronic platform that allows individuals to develop interactive and programmable projects. So one of the most exciting aspects of Tinkercad and Arduino is their integration. Tinkercad allows us to virtually connect components such as LEDs, resistors, sensors, and even Arduino boards to create interactive circuits. We can write and upload any Arduino coding directly into the Tinkercad, simulating the behavior of our physical circuit in a virtual environment. So let's moving on to the next, which is how does theoretically our early flood detection system works. So first, this project is focuses on detecting and predicting floods. It will monitor the river levels using ultrasonic sensor processing techniques, which is allow us to get the accurate and quick flood estimations. So next, it is placed alongside a river and incorporates a well-designed system equipped with an ultrasonic sensor, buzzer, and also the LED light. So it will activate the buzzer when the system between the ultrasonic sensor and also the water levels is below 200 cm. So the LED light will change the color and the buzzer will become louder, and also it will display the message danger flood. So now let's move on to the component list for our project in Tinkercad. So first is the Arduino Uno. So it serves as a virtual controller board that allows us to write code, control electronic components, and also simulate interactive projects. So next is the breadboard. So breadboard facilitates the connections and arrangement of electronic components, which is enabling circuit prototyping and testing without physical wiring. So next is the resistor. So this resistor serves to regulate electric current, modify voltage levels, and safeguard components by impeding excessive current flow. So next is the potentiometer. So it functions as a controllable resistor with adjustable resistance through knob and slider rotation, facilitating voltage or current regulation within a circuit. So now let's move to our four last components used in the Tinkercad. So which is the buzzer, produces audible sound when supplied with the electronic signal, commonly utilized for audio feedback, alarms, and interactive project applications. So next is the LED light. So it will emit light when electric current flows through it, typically utilized for status indications, visual feedback, and also lighting effect. So next is the ultrasonic sensor. It will measure distance by emitting sound wave and detecting the reflection of object. So last but not least is the LCD display. So it will emulate a physical display by presenting alphanumeric characters and graphical informations, which is enabling the output of the text, numbers, or visual data in virtual projects.
Our flood detection system utilizes an Arduino microcontroller to monitor water levels and provide real-time alerts. It consists of ultrasonic sensor as an input, and also for the output, there are LEDs, buzzer, and LCD display, as you can see in the slide. I also have already labeled each of the components function in our system. Now, I will explain about the inputs and outputs function of our system. First and foremost, for the input, there is a ultrasonic sensor to detect water level, whether the water is increased or decreased at the let's say river. And for the ultrasonic sensor, we connect the sensor trigger pin at port 5 of an Arduino, which is used to trigger the sensor, where echo pin at port 4 of an Arduino. And now for the outputs of our system, where we can see what will happen in our system when the potential flood is coming to the area. The first one is LED, the second one is a buzzer, and the last one is LCD display. The first one is LED. The LED pin is connected to pin 12 and 13 of an Arduino, which it will indicate whether the area is still safe or not, or the danger or which is flood is coming to the area. And also the second one is buzzer. Buzzer we connected to pin 6 to as it can generate the sound. As for the LCD display, as it will indicate the distance from the sensor to the water, we connected to the pin 11, which is connected to the RS, which is register select pin. And also at pin 10, we connected to the enabler pin. And lastly, at pin 9, 8, 7 and 3, we connected to the data pin of the LCD display. Right, as you can see in the slide, there is a schematic diagram of a circuit of our system, which indicate everything that we connected through wire to the Arduino and also to the component. See here, this is our system code, where it will measure the distance and warns us if there is a potential flood. It displays the measurement on the screen and sounds an alarm, lights off a light and shows a warning when there is a potential flood. This code, as you can see over there, initializes the system. It sets up the initial configuration, as you can see on the top of the coding, and continuously checks the water level. If there is a potential flood, it will trigger the alarm and shows the warnings and activates a light. This code will loops continuously to monitor the water level and provide the alerts when needed. As you can see in the code, I put the command at every line of the code, where you can read and know what it will do to the code. Are the results. This is the state where our systems, if the water level of the river is not increases yet, means the area is still safe and sound. The green light, it will indicate the water level does not exceed the danger alert yet, as it's still 2 meters away from the sensor. As you can see in the slide, as it displays, as the LCD displays the distance of the water from the sensor, which is 220 cm, which is equivalent to 2 meters and 20 centimeters. If there is a potential flood is coming to the area, as the water level is increases, the LCD will display danger, flood, and the buzzer will trigger sound, and also LED light will turn to red to alert the people around the area.
Good afternoon everyone. As I stand here today, I will explain about the discussion. Without wasting any time, I will go straight to the point. The table displays the result of the ultrasonic sensors measurement of the water level. By analyzing the data, we have classified the measurement into 3 categories, which is low, medium and high. This classification helps us understand how the distance between sensors and the water surface relates to the water level in the river. When the sensor detects a short distance to the water surface, it indicates a high water level in the river. This suggests that the river has experienced a substantial increase, possibly due to the heavy rainfall or greater inflow from the tributaries. As a result, the risk of flooding becomes more significant during these periods. In this picture, the flood alert system warns and monitor potential floods using an ultrasonic sensors. When the distance measures below 200 cm, it triggers warning indicators. These include a gradually increased volume, buzzer, and high visibility LED turning red. An LED display shows the distance, allowing users to track the flood threat in the real time. When the distance reaches 200 cm, the display shows danger, flood, urging immediate action. The system comprehensive approach enhances safety and enables proactive measures to mitigate flood impacts. Apart from how the system works, we move into the components that have in our system. The flood alert system incorporates several essential materials to facilitate its effective operation. These materials include an Arduino Uno, an ultrasonic sensors, a buzzer, LED lights, and also LED display. As you can see in the slide, Figure 1 illustrates the use of the Arduino Uno as the central component in the system. It receives and interprets voltage output from the voltage sensor. After that, Figure 2 shows the ultrasonic. The ultrasonic sensors plays a vital role in the system by measuring the distance between itself and the water surface. It uses sound waves to determine this proximity, allowing the system to accurately assess the risk of flooding. After that, in the third picture, it is the buzzer. The buzzer sounds louder as the distance measured by the sensor get closer to 200 centimeter, and also warning people about the flood danger. After that, as we can see in the fourth picture, this is LED lights. LED lights in the flood alert system turn red when the distance measured by the sensor is below 200 cm. This change in color signal a higher flood risk, quickly catching attention and indicating potential danger.
Hi, I'm Narasha Mina'a. So I will proceed with conclusion. Arduino Uno is create intelligent flooding forecast that warning system use the water and rain sensor that can detect the distance how the flooding come. So from this project, it improve the awareness of people around to get ready if the flood happen, and it will reduce the damage occur like economical and so on. So from this project, if they have more research that can improve the system and ensure their effective integration into flood detection operation and maximize its advantage for people around. So that's all from us. Thank you.